The architectural design must consider the climate region of the building site, divide the climate zones, and put forward different thermal performance requirements of building envelope for each zone, so that the designed building can well adapt to the local climate. According to GB 50176 Civil Building Thermal Design Code, the building thermal design is divided into 2 levels, and the level 1 is divided into 5 zones, including severe cold zone, hot summer and cold winter zone, hot summer and warm winter zone, temperate zone. The main indicator of the first level zoning is the average temperature of the coldest months and the hottest months, and the auxiliary indicator is the continuous number of days when the daily average temperature is larger than or equal to 5 degrees Celsius or higher than or equal to 25 degrees Celsius. Severely cold zone must meet winter insulation requirements and may not consider summer heat proof. Cold zone meet the winter insulation requirements, and some areas take into account summer heat proof. Hot summer and cold winter zone must meet summer heat proof requirements and properly take into account winter insulation. Hot summer and warm winter zone must meet summer heat proof requirements and may not consider winter insulation. Temperate zone. Some areas are required to consider winter insulation requirements, but summer heat proof may not be considered. The heating period refers to the number of heating days calculated by the architectural design of a certain area. That is, the number of days when the average daily temperature is larger than or equal to 5 degrees Celsius over the years. The average outdoor temperature during the heating period refers to the average daily average temperature of the outdoor during the start and end days of the heating period. The number of heating degree days is obtained by calculation. That is, the number of days in the heating period multiplied by the temperature difference between the indoor reference temperature of 18 degrees Celsius and the average outdoor temperature during the heating period. The number of cooling degree days is also obtained by calculation. That is, in a year, when the average outdoor temperature is higher than 26 degrees Celsius, multiply the degree higher than 26 degrees Celsius by 1 day, and then accumulate this multiplication. The average temperature of the coldest and hottest months can reflect the local degree of cold and heat. However, since the focus of building energy-saving design is to control the energy consumption of heating in winter, the energy consumption of air conditioning cooling in summer, and the use of natural ventilation in transitional seasons, the demand for heating and air conditioning cooling is not only based on the temperature, but also with the continuous low temperature or high temperature. If the temperature of place A is larger than that of place B, but the temperature of place B continues to be cold for a longer time, the heating demand of the two places may be the same. Since heating degree days and cooling degree days include 2 factors, the degree of cold and heat and the duration of cold and heat, they can more accurately reflect the demand for heating and air conditioning cooling as an zoning index. GB 50352 General Principles of Civil Building Design is slightly different from the zoning details of the Building Thermal Design Code. The index has increased humidity, and the requirements are more detailed. Urban climate refers to the special urban climate phenomena caused by urbanous construction. The basic characteristics of urban climate are mainly as follows. 1. Urban heat island phenomena. Under the same air temperature, the urban effective temperature is significantly higher than that in the urbans. 2. Urban wind. In the case of high background wind speed, the rough urban underlying surface makes the urban average wind speed significantly larger than that of the suburbs. The wind direction distribution is basically irregular, and some areas form no wind areas and strong wind areas. When the background wind speed is small or no wind, The urban wind field is a thermal turbulence caused by the urban heat island phenomena, which is often regarded as a polluted wind. 3. Low humidity and loss of precipitation. Due to a large number of buildings and a large area of hard road pavement, the natural evaporation in the city is reduced. The absolute humidity and relative humidity of the air are larger than those in the suburbs, and the daily fluctuation pattern is also different from that in the suburbs. However, due to the higher concentration of dust in the air in urban areas, fog and cloud cover are higher than in suburban areas, and there is more precipitation than in suburban areas. 4. Solar radiation and sunshine. Higher concentrations of dust and clouds in urban air make solar radiation less intense than urban areas. However, the three-dimensional underlay absorbs more solar radiation, resulting in a total heat gain from solar radiation that is similar to that of the suburbs. The sunshine conditions in the city are worse than that in the suburbs, and the total sunshine hours and sunshine rate are both larger than those in the suburbs. There are two main reasons for the formation of urban climate. 1. The attributes of the urban surface have changed. First, because the city is a three-dimensional underlying surface, the absorption rate of solar radiation and the friction coefficient of the ground wind increase, and the long-wave radiation coefficient to the sky decrease. Second, the properties of the building surface materials change, the breathing function is lost, and the solid gas two-phase sensible heat exchange is increased. 2. The high-density population distribution has changed the energy and resource consumption structure. First, the large amount of greenhouse gas emissions increase the greenhouse effect of the city. The second is the large anthropogenic heat emission. Think about it. What architectural design methods can be used to reduce the effect of outdoor heat? How to test the wind field of the building complex? What analysis software is there?